So, if your digital life is anything like mine, you are just sitting on a vast, untapped library of content.
Oh, absolutely. A mashing of it.
Right. We're talking about all that video content, has gold in it. Maybe it's a 10-hour raster class or, dozens of recorded company trainings.
That 100-hour documentary you swear you're going to finish one day.
Exactly. And the problem is, these videos are basically inert. They're knowledge graveyards. The only way in is to manually scrub through the timeline, hoping you find something. You can't just ask a 60-hour video, hey, what were the 3 key arguments about macroeconomics?
Not until now, at least.
But what if you could? What if you could just upload all those hours and we'll chat with them? Not just search, but have a real intelligent conversation that pulls out precise answers from days of footage.
With the exact video references, too.
That's what we're getting into today. We are deep diving into the framework that promises exactly this. It's called VideoRAG, and the desktop app is Vimo. Our mission here is to really dissect the engineering that makes these intelligent video conversations possible, and more importantly, how it masters what they call extreme long context processing. We want to understand how this can transform your passive archives into active instant knowledge sources.
And this is so significant because it's not just a small improvement on search or indexing. This is tackling the most paralyzing challenge in multimodal data.
What do you mean by multimodal?
Well, with text, it's pretty linear. It's easy to segment. But video has visual data, audio, the transcript, and this crucial temporal context, how things change over time, all woven together.
Right.
Traditional systems, they really struggle to maintain that context for more than, say, 30 minutes.
Yeah.
You start talking hundreds of hours, and they fail completely.
Huh.
VideoRAG's promise is to keep that retrieval ability, that deep accuracy, no matter if the video is 5 minutes or 5 days long.
And that's the real insight we're chasing today, the ability to just conquer scale. So let's start with the interface that delivers this power, the Vimo desktop application.
Yeah, for the user, the core idea is that it treats a 100-hour video archive with the same analytical depth as a 5-minute clip.
And they've done a great job removing the friction, making it accessible. You just upload your video.
Oh, yeah.
And yeah, it handles all the common formats, MT4, MKV, you name it, and you're immediately in a natural conversation.
No query language, nothing complex.
No, you just ask questions in plain English. But let's move past the drag and drop stuff, because the real power user features are what makes this so much more than just a smart transcriber.
Absolutely. That user-friendly front end is hiding some serious engineering. When we talk about extreme long context processing, I mean, videos up to hundreds of hours long, that is the game changer.
What does that actually mean for, say, a professional trying to learn something?
Well, think about it. If you're catching up on a year's worth of internal meetings, maybe 80 hours total, before you were paralyzed, you couldn't watch it all, so that knowledge stays locked away.
Right. You just give up.
Okay. Now you can ask the system. Synthesize all discussions about the Q3 product roadmaps, shift in focus, and you get an answer. Instantly, cross-referenced, you go from 80 hours of passive viewing to targeted knowledge retrieval in seconds.
I think the most powerful feature, especially for researchers, has to be the multi-video analysis. I mean, chatting with one long video is one thing, but what if you could upload 3 different 10-hour documentaries on the same topic?
And ask it to compare them.
Yes, ask it to compare the primary sources they each cite.
That's where the real power of synthesis comes in. Multi-video analysis lets you expose inconsistencies or track how a narrative changes across different sources all at once. And the retrieval is so advanced, you're not just getting a sentence back.
You're getting the clip.
You're being led to the specific scene, the visual evidence, cited down to the second. It's like an instant targeted literature review, but for video.
It just sounds revolutionary. But it brings up a huge engineering question. How? Traditional systems can't do this. So how did they build this engine? Let's get under the hood and talk about the VideoRAG algorithm. The sources all emphasize this novel dual-channel architecture. What problem is that actually fixing?
It's designed to fix what you could call the context crisis.
The context crisis.
Yeah. When language models process really long sequences, they have context window limitations. They start to forget details from the beginning by the time they reach the end.
Right. The early information just falls out of memory.
It does. And this dual-channel architecture, it addresses that by treating the data in 2 complementary ways. It makes sure both the content and the connections are preserved across time.
Okay, let's unpack that first channel. They call it graph-driven knowledge indexing. Help me visualize that. If traditional analysis is just one long linear timeline, what's a knowledge graph doing differently?
Okay, think of it this way. A traditional system processes video, like reading a 100-hour-long scroll of text.
Okay.
If you want to find the link between something on page 1 and something on page 500, you have to read everything in between every single time. It's slow and it's error-prone.
Right.
Graph-driven knowledge indexing is more like building a comprehensive, multimodal semantic map of the knowledge.
A blueprint.
A blueprint, that's a great way to put it. The system identifies key entities, people, concepts, objects, and it actually structures the relationships between them. So if an expert mentions climate policy A in minute 10, and then a graph showing its impact appears in hour 40.
The knowledge graph connects them.
Exactly.
Uh-huh.
It doesn't just note that both things exist. It explicitly maps that semantic relationship. This structured indexing transforms this massive long video into, well, into concise knowledge representations.
I get the idea of the semantic map organizing the meaning, but how does that mapping process not take forever itself? Are we just trading viewing time for equally long processing time?
That's a fair question. The goal is a massive net gain in time. And while that initial indexing does take time, it's a one-time process. Once it's done, you've turned an inert asset into a perpetual queryable knowledge base. The architecture is really designed to make that initial investment efficient. We can talk about the hardware later, but it's surprisingly accessible.
Excellent. Okay, so that's channel 1, the semantic map. But we still need to preserve the actual visual and temporal flow. That's where the second part, hierarchical context encoding, comes in.
It does.
It sounds incredibly technical, preserving spatiotemporal visual patterns.
Right.
What does that mean in plain English?
It is jargon-heavy, but it's so critical. This encoding is what prevents that memory loss on the visual and audio track. So imagine you're watching that 60-hour documentary on the history of flight.
Okay.
In hour 1, they show a really detailed 1920s blueprint for an early aircraft wing. Then, in hour 55, they show the final design for a modern jet engine.
A huge time gap.
A massive time gap. Hierarchical context encoding is what ensures the system connects those two visuals. It recognizes the pattern evolution, the design lineage. It maintains the visual narrative thread over that whole time. It captures how events unfold, what objects appear where, and what the connection is, no matter how long the video is.
And that directly supports the adaptive retrieval. So a query about the wing design from the 1920s immediately connects to the visual evidence presented 54 hours later.
Precisely.
So we have the dual channels, the graph-driven indexing organizes all the meaning and relationships, and the hierarchical context encoding makes sure the system remembers the specific visual and temporal details, even at a massive scale. And together, they let a text query perfectly align with the multimodal content.
The actual video clip, not just the transcript. It's a true cross-video understanding.
This sounds like a beautiful piece of engineering in theory, but what really solidifies it for me is the performance data. We always say a system is only as good as the tests it passes, and because existing benchmarks were way too short to test this extreme long context, the team had to build their own, the longer videos benchmark.
Correct. And creating this benchmark is almost as important as the algorithm itself. It sets a new standard for testing context retention. The scale is it's staggering. We're talking 164 videos, totaling roughly 134.6 hours of content.
134 hours.
And they ran 602 different queries against that data set. If you're a machine learning practitioner, you know just building that benchmark is an immense task.
Let alone scoring well on it.
And crucially, this wasn't 134 hours of, boring surveillance footage. The content diversity was picked specifically to stress test the system. About 64.3 hours were lectures, which tests for dense specific fact retrieval.
Which is probably the easiest category, right? Lectures are usually pretty linear.
Relatively, yes.
Yeah.
But then they included 41.9 hours of entertainment.
Which is totally different.
A whole different dimension. Now you're testing for narrative complexity, tracking characters, emotional context, fast scene changes. And AI has to follow subtle plot points over dozens of hours. That's much harder than summarizing bullet points.
In the last category,
28.5 hours of documentaries. This demands everything. High accuracy fact retrieval, multimodal synthesis. You often have talking heads, B-roll, visual evidence, all at once that has to be correctly connected. This benchmark proves the algorithm is robust across wildly different kinds of complexity.
that breakdown of the benchmark really clarifies the challenge. So let's circle back to what you mentioned earlier, feasibility. When you talk about hundreds of hours of multimodal data, I'm assuming you need a supercomputer, a huge cluster of hardware.
That would be the traditional assumption, yes.
But the sources claim this whole system can run on a surprisingly accessible hardware setup. They specifically mention a single RTX 3090 with 24 GB of VRAM, a single 3090 for 134 hours of content. That sounds almost too good to be true. Is that for the retrieval or the initial massive index build?
That is a critical distinction. The efficiency claim is primarily about the indexing and retrieval operations. The architecture is just highly optimized to manage the memory load for these massive graphs and hierarchies. Now, the initial ingest of 134 hours still takes significant processing time, of course.
But once it's indexed,
Once it's indexed, the fact that you can manage the full retrieval and querying pipeline on a single high-end consumer card like the 3090, it just dramatically lowers the barrier to entry for everyone. You don't need a server farm just to query your own video archive.
that completely changes the landscape for research and for companies.
It does, and they're leaning into that. Not only is the algorithm state-of-the-art on this incredibly hard benchmark, but the entire VideoRAG implementation, the architecture, the research from their 2025 ArcGIF paper, it's all open source.
Which means the whole field is going to move faster.
Exactly. That transparency ensures these tools are going to evolve rapidly everywhere.
So to bring it all home, what does this all mean for you, the listener, who's sitting on that massive backlog of videos? The core takeaway is that VideoRAG and Vimo aren't just summarizing. They're providing deep, chat-based understanding. And they're doing it with those two big innovations, the structured, graph-driven indexing and that specialized hierarchical encoding. It's a re-engineering of how machines remember, built to finally conquer the length limits that have always plagued video.
Precisely. This transforms those inert archives, lectures, company history, personal records into these interactive, perpetually queryable knowledge bases. It means deep knowledge retrieval is no longer this slow manual process. It's quick, it's accurate, and crucially, it leverages the full multimodal context, the visual proof, and the audio without you having to invest all that time.
It takes the knowledge and makes it instantly actionable.
It does. And this brings us back to that feature we discussed earlier, multi-video analysis. It raises, I think, a really provocative thought. If an AI can instantly analyze and compare themes and facts across 164 separate videos that might have conflicting data or viewpoints, how does this fundamentally change the way we approach critical thinking and source evaluation? When systematic instant comparison across dozens of sources becomes standard, what new objective insights might emerge that were just impossible to trace before because of the sheer amount of manual labor involved? Think about that power of instant synthesis as you approach your next deep dive.